Let's discuss how to understand rates of change. To begin with, let's consider the familiar slope of a line. You're probably familiar with the formula that the slope is equal to the difference in the y-coordinates over the difference in the x-coordinates. In this case, we're talking about finding the slope between 2 points, x1, y1, and x2, y2. This idea of slope is really based on the idea of a slope of a straight line. So consider a graph where we have our x and y axis, and we have some line here. If we want to talk about the slope of that line, you're probably familiar with the idea of rise over run. We want to think about, as we move horizontally, how much do we rise? And that would lead us to the idea of slope. The same idea of slope can be generalized to apply to curves. If we look at the curve here, on this section over here of the curve, you're probably noticing that the function is increasing. We would say that that section has a positive slope. Whereas over in this section here, the function is decreasing, and we would say that we have a negative slope. Similarly, over here on this section of the graph, the function is again increasing, so that would be a positive slope. You might ask, what exactly is the slope at those various points? Well, for curves, we don't have a straight line, so the slope isn't constant. The slope at different parts changes. Notice here we change from positive to negative to positive again. And in fact, even more so, the slope changes the value. So in order to talk about the slope of a curve, we're instead going to talk about the slope of the tangent line to the curve at a given point. So for example, at this point here, if I draw a tangent line, I'm going to say that the slope at that point is roughly equal to the slope of the tangent line. In this way, the same idea of linear slope, the difference in the y-coordinates or the difference in the x-coordinates, will apply to curves. There's a couple special cases we want to be on the lookout for. One is that of a constant function. Notice here the function value is always 1. The y value is always 1, so in this case, the slope of this graph would be 0. Another special case would be something like the absolute value function. Notice here, on this side I have a positive slope, and on the other side I have a straight line negative slope. But at this point right here, the concept of slope doesn't make a lot of sense. Is it positive? Is it negative? Is it a zero slope? So sometimes we may have points at which the slope is undefined. These ideas of slopes for curves will be better defined when you take a calculus course. To begin with though, let's think about some simple problems we can do now. Consider the following. We want to find the average rate of change of the function f of x equals x squared minus 2 on the interval from x equals 1 to x equals 3. In order to do this is a curve, but since I'm on a fixed interval, the average rate of change would just be the rate of change over that particular interval. In this case, our average rate of change, the same idea as before, the change in y-coordinate all over the change in x-coordinate. So for this particular problem, we need to define our points. When our x value is 1, my y value would be 1 squared minus 2. Or in other words, that's 1 minus 2, so the point 1, negative 1. Similarly, when x is 3, my y-coordinate would be 3 squared minus 2. Or in this case, that would be the point 3, 7. So I'm going to utilize these 2 points to find the average rate of change of my function. So going back to my formula, so average rate of change would be equal to, I can choose these points in any order. It doesn't matter which one you decide to be x1 and y1 versus x2 and y2. In this case, I'll pick this first one to be x1, y1, the second one to be x2, y2. And if I go ahead and plug into my average rate of change formula, that would give me negative 1 minus 7 all over 1 minus 3, or negative 8 all over negative 2, which simplifies then to be 4. So the average rate of change of this function on that particular interval is 4. What does this mean? Well, let's go ahead and look at the graph to kind of understand what this idea means. First off, if we graph x squared minus 2, that looks like our standard parabola shifted down 2 units. So it would look something like this. Looking at that, I want to look at the 2 points in question. Here's my first point, 1, negative 1. And my second point would be up here somewhere. This would be the point 3, 7. The fact that the average rate of change between these 2 points equals 4 is basically telling me that if I draw a secant line connecting those 2 points, that line has a slope equal to 4. So that's how we find an average rate of change. Let's take a look at another problem. Answer the following questions for the graphs shown below. Are the function values increasing or decreasing? And is the slope of the function increasing or decreasing? Alright, let's look at the first function. Over here, notice my function is going up. As I go along this curve, my values are getting larger, so that means the function is increasing, so the slope of the function is positive everywhere. So the function here is increasing. Similarly, on the function on the right, the function values are getting larger, so this function is also increasing. Now let's look at that second question. This is asking us, is the slope of the function increasing or decreasing? This is a tougher question. Let's look at the function on the left here. In this regime, near the beginning, notice my slope is quite small. It's pretty near a flat. I'm walking up a very gradual hill if you imagine walking from left to right. Whereas, as you move along the curve, it gets much steeper. So it's quite steep over here. And if you get over to this regime, it's very, very steep. So in this case, we would say that the slope of the function is increasing, because as I move along, the slope is getting larger and larger. Let's contrast that with the function over here. Right here, if you look at this function, walking uphill here, the function is quite steep. So that is a very large slope. Whereas over here, if you imagine walking left to right, that's not as much of a slope. And finally, over here, that's getting closer to flat. So in this case, our slope is decreasing. As you move from left to right, the values of the slope is going down. Now you've had a chance to work with and understand how to deal with slopes and rates of change for different types of problems. You will also see these in application problems. Thank you, and keep on learning.